Hey everyone, in today's video we're going to have a look at design communication. So this is one, most likely going to be in paper 2, the 1.5 hour, but there may be a couple of little questions here and there that could crop up in paper 1. A lot of it's not going to be a massively long video. A lot of it is stuff that we've covered before in skills, assessments and that kind of thing, and stuff you've done over at GCSE. It's just making sure you understand the names of things and why they're used. Okay, so first thing we'll look at is design reports. So this, you will not have done this in school or college yet. This is something very much an industry standard type of thing. So this is a record of a project that is left after the project is finished. So if you imagine the project you're doing now, if you were doing this in industry, and you would have to do it at university as well, is once a product is completely done, you would write a design report on it, and then that will get filed away so that for future reference later in the company or for whoever, if they want to go back and look at what the train of thought was, what resources you used, what the possible design ideas were from. So essentially it's kind of like the design folder you're doing now, but in a more formal academic way. So there are 3 sections to it. So this starts with an executive summary that basically summarises the whole design up, the features to it, what it does, why we've done it that way, what the thought processes were to it. Section 2 is the introduction. So it basically explains the design brief, the client, the problem you came across, how did you solve it, that kind of thing. So this is, like I say, you're planning out going, right, this is what the project we did was, and here's how we went about going through it. Then section 3 is known as the conclusion. It explains the chosen designs, any problems they face and how they were overcome, compares the selected designs compared to the specification and how it can be improved. Now that obviously is something you do quite a lot, and you will be doing in your design section, your evaluation sections. Designers may also have to write up and test up any testing they did during their project as well. So from that, it's fairly similar to the sort of folder you're doing at A level. But again, it's a more academic a document that way, but you're still going through the whole day. You're still saying this is the product we came up, and then the rest of the folder is showing how you came up to what you did. So explaining what the problem the client was, what the whole issue you're trying to solve is, and then here are the designs, here's our thought process, and basically you're justifying how you came up with what your final product was that you said in section 1. Okay, so you're justifying and explaining that this is all of this project, and we end up making this product to sell it in industry. This is the one, we're confident this is the one we're going to make the money from, and this whole document will just show you why that is. So, graphs, tables and charts. Hopefully a lot of these have been seen in maths before. Some of them are very, very simple. Some of them take a little bit more reading, but not a lot. A lot of it is basically just how do you show data and how can you read data from it. It's just important. Some of these will come up in your exams, particularly obviously in the maths content, especially if you come across an anthropometric data question, which are popular in some of the exams. So they may show you things like the data tables, but simply for you got like bar charts that just show you what the thing is, how many people, and it's a really easy, quick way to see how many people or whatever the thing is that you're trying to show. You got pictographs. Again, really easy, probably quite primary schooly, but it's this thing there just to show you some data. Really easy to understand, but there's no accurate. You're not really getting any accurate data from that. So line graphs. So these shows data changes over time. Sales of a product, for example, how popular something is. I get a line graph every time I do all your marketing for your coursework, and it can show me where you were to where you are, and I can see over time who's getting better, who's getting worse, who's staying where they are. So that's a very useful one, particularly if you are into the analysis of information, and also if you say you go into engineering and you're changing little bits here and there to try and see like certain changes and see what changes have made positive improvements, what changes have made negative improvements. Again, talk about bar charts, really simple to use. It's important to note bar graphs have the gaps, which you see over here. Histograms, very, very similar. There is no graphs. So they're usually shown a range of distribution of data. So again, this is very popular for things like anthropometric data. And then you got bar charts, again, nice and simple, but not massively, always normally done in percentages normally, not massively accurate. Then data tables, very useful things like anthropometric data, cutting lists, which you'll have to do when you make your actual physical product as well. So typically, the most common ones that will come up in your exams probably are histograms and data tables, but it's just important to make sure you can understand what the others are and how they're used and what the benefits are. The most accurate ones really that you can have. Data tables, line graphs, histograms are most accurate ones. Most common ones to come up probably will be histograms and data tables. So freehand sketching, really simple. Everyone knows how to freehand sketch at this point. We've done loads of different kinds. They could be isometric, it could be oblique, anything like that. It's a nice, really quick, easy sketches to do with like your initial designs, initial sketch ideas. It's nice and easy to get ideas down because you don't need anything else. You just need a pencil or a pen and a piece of paper, and you can quickly just get ideas down. You got digital photography, so usually used for graphic design. So anyone that's doing graphic design at A level currently, where freehand drawing would not show the design, and so you're not going to be able to do anything like that neatly freehand unless you are a proper artist. Most commonly used for things like billboards, film posters, in magazine posters, those sorts of things. Cut and paste techniques. So these are typically known as mood boards, which we've done before in your coursework. So this is where you just get loads of like images to help inspire whatever it is you're doing, whether it's colour themes, shape themes, materials, techniques, whatever it may be. 3D modelling. So use when a drawing would be difficult to show features of a design. You can use a variety of different materials. So obviously things like cardboard, cards, styrofoam, HIPs, PLA if you're 3D printing. So 3D modelling is massively helpful, and obviously you will do quite a lot of that at A level anyway. Isometric drawing. So we've covered this. So the idea being that everything's at 30 degrees, everything is cut from the corner and going outwards, and use the grid paper to do it. Once you're comfortable, you can remove the grid paper. Oblique drawing, similar to isometric drawing, except that the showed from the face onwards, so rather than the edge. So if you see isometric, you see the edge is the beginning at the front. Oblique is the face. So it still shows 3 edges to it. This is very much like, if we're going to grade it, I would say this is oblique drawing. Typically is primary school level 3D drawing. That's typically the first way you learn how to draw 3D, and then as you get better, you go off into isometric drawing. Perspective drawing. So you got 1 or 2 point perspective most commonly, where you have your corners, you have your horizon, and everything goes back to the vanishing point. So we did have a go at doing this, so you could do things above and below the horizon, so you can see above the shape or below the shape. Orthographic drawing, also sometimes known as working drawing. So this is absolutely crucial, especially A level and beyond. If you go to university, you do engineering, this kind of thing. Obviously this is quite a simple shape, and it's showing a children's toy train. And we have covered orthographic drawing before, but it's very clear because everything's 2D in 2D, and this is why it's so important to do CAD work, because most CAD software, particularly Fusion, will do the orthographic drawing automatically for you. And this is basically the drawing that have all the key measurements, everything will be in line, and it's really easy to see all these key details ready for manufacturing. Exploded drawing, again, very, very useful, and again, it's something Fusion can do for you once you know how. Lets you show all the parts in this side of it, so things like screws, bolts, ribs, bushings, any other extra features you might find on the inside that will somehow be hidden. Typically, most commonly, you probably see that on things like IKEA furniture that you've got to assemble and that kind of thing. And you notice that everything is in line the way it should be, so it should all fold back together again. CAD drawings. Now, obviously, we've got loads of different CAD softwares that exist in the world. The ones in college we use are Fusion 360 and 2D Design. Some are better than others. A lot of people like SketchUp. SketchUp really is like GCSE level. As you move further up, you get more confident with it. The good ones, I know some people like to use SolidWorks or Creo. A lot of it is down to preference. Some software is better than others because of certain features that it has. We use Fusion 360 in college. I think it is the greatest piece of software of all time. Like I said before, it will do your orthographic and your exploded drawing for you. I know some people try and shy away from CAD, but really, if you're going into a design industry or university, especially now, CAD is going to be used a lot. So there's a reason why it's there. It also lets you you can put materials on there, you can do rendering where you put it into an environment so you can see how it looks. All that makes it better, so when you go to a client or you test something, it's there, it's ready, you can see how it will all look. And then annotations. Again, we all know what annotations are, but it's just making sure the whole reason you have annotations there is just because you've sketched something and you know what you're doing, you may then send your sketch off to someone that's in a different department or a different building or a different city, and they weren't there when you did it. You're not there to talk over their shoulder to explain your thought process. So these annotations are all there to explain all the key information that's in your head that you need to explain to the person. Obviously, it needs to be relevant. You can't just say, like, oh, yeah, my favourite colour is blue, I like pizza. But it would be stuff that, like key materials, any key features to the design, tips like any parts of manufacturing, any key areas that need to be like really noted, that sort of thing. So what I would like you to do is, can you write a design report for the last project you made? So that way may well be the GCSE project you made in year 11, or you won't really have got to the stage where you can do a design report for your A-level work, because we've not done enough of it. But have a go at writing a design report, and then can you explain the differences between bar chart, pictograph, histogram, line graphs, pie chart, and data tables? So that is communication techniques. Like I said, nothing really brand new, but it's just, some of it you may think, oh, it's common sense, of course I know what that is, Simon, why are you telling me? But it's just important you know what they are, because some of them will come up in exams quite regularly, and it's just important you understand. Obviously, not all drawings are equal, not all drawings are used the same way, so just making sure you know what drawings to use when, and so on. If you've got any questions, please send me an email or message me on Teams and I'll get back to you.